Okay, so intermediate form and indeterminate form and L'Hopital's rule. So indeterminate form means we get 0 over 0, maybe. We end up with 0 over 0 when we're looking at the limit, infinity over infinity, infinity times infinity, and these could be positive or negative. Anytime we get something where we don't know, like you can't determine what the limit is, we can use L'Hopital's rule. But we can only use L'Hopital's rule, like if we want to use it multiple times, we still have to get those things like 0 over 0, infinity over infinity. Otherwise, we stop and we're finished. All right, so let's look at this one. If I look at the limit as x approaches -5 and I plug in -5 for x on the top, I plug in -5 for x on the bottom. So if I try to do direct substitution, I get 0 over 0. That's indeterminate form. So applying L'Hopital's rule says that if I have a function whose limit, when I plug in the values, limit approaches indeterminate form, then I can take the derivative of the top and the derivative of the bottom. We are not applying derivative rules like quotient rule or anything like that. You are just taking, so if I have f of x over g of x and I end up with indeterminate form, then I can keep this, the limit as x approaches a, and I can take the derivative of the top function and the derivative of the bottom function and try direct substitution again. So I'm going to do that here. So I have 2x on the top over 1, because the derivative of -25 is 0, derivative of 5 is 0. Now I'm going to direct substitute. I'm going to plug in -5 and I get -10 for that. All right, so once I can direct substitute, I'm finished. I have my answer. All right, let's try this one. We're looking at the limit as x approaches infinity. All right, so when I plug in infinity, I get infinity on the top, I get infinity on the bottom. L'Hopital's rule says I can take the derivative, and you guys may be looking at this and going, we can divide by x cubed. You're right. Or you may be looking at it from the algebra 2 side and saying it's 5/7 because the exponents are the same and this is just in behavior. You are also correct on that. So you have lots of tools in your toolbox now to be able to do this. So I take the derivative and I get 15x squared minus 2 over 21x plus 0. So squared, sorry. So still no. So I keep going. If I plug in infinity, it's still going to infinity. So I get 30x over 42x. And now I can reduce. So 30 over 42 is my limit. Oops, I forgot to say infinity. 30 over 42 is the value of that limit. And I can reduce top and bottom by 6. And so I end up with 5/7, which we know is our horizontal asymptote if we're going to be graphing this. All right, so some things to watch out for. If we end up with something like infinity plus infinity, or infinity plus 0, like those things could happen. We want to, if it's an addition, blah plus blah, we want to make it into one fraction so that we can use L'Hopital's rule. If it's something where we have an exponent up here that we need to get down to the front, then we're going to apply the natural log to both sides of my equation so that we can move that exponent to the front, and then we'll solve for y, and then we'll be able to evaluate that limit. So those last two things we're going to look at when I see you again. Just wanted you to have the foundation of what we're going to be doing with indeterminate form and L'Hopital's rule.